so today we're going to look at section 6.5, Law of Cosines. And the question comes up is, what do we do in a non-right triangle if we can't use the law of sines? So we just previously learned the law of sines. And what if I can't use that? What if I don't have a right triangle and I can't use the law of sines? Well, we have the law of cosines. Here's the law of cosines. I gave you three of them, the three forms of it. It's all basically the same form, just from different perspectives. So in this scenario here, you'll take a look at it. And what I need here, okay, if you look at this, when we did the law of sines, remember we had to have one complete ratio. And that comes when I have two angles and a side, or two sides and an angle. The side of the angle will be opposite and you have a complete ratio. Well, the law of cosines has the scenarios when I have these two setups, a side, angle, and a side. So a side, then an angle, and a side. See, I can't complete a ratio with that. So if I have a side, angle, side, or if I just have the three side lengths. If I don't have any angles, I can use law of cosines to find the other pieces of missing angles. And so I'm going to show you how to do some of those things here today. So here's the law of cosines, and I want you to notice here something, and I'll probably say it here in my notes here in just a minute. Yep, there it is. That it's very similar to the Pythagorean theorem, see? C squared is A squared plus B squared, right? That's the Pythagorean theorem in a right triangle. Okay, so this part over here is the extension. So when I don't have a right triangle, this is kind of like the Pythagorean theorem without the right triangle part of it. And so this part over here is the other thing. So when I have a 90-degree angle, the cosine of a 90-degree angle is 0. So that's why this whole term is gone, and I just have the Pythagorean theorem. So the law of cosines, that kind of helps you remember what the rule is. And you'll notice here, no matter which form I take, is whatever this side is right here, then it's the cosine of that angle. See? And then it's this one, and then it's the other two squared being added, and then minus 2 times those same two numbers times the cosine of the angle opposite that side. Okay, so that's the formula to help you remember it. I just wrote all three forms down for you so you can see it. And so we're going to do a problem. I'm going to go off the journal page, and number 3, and I think I did 3A, so right here. So let's go ahead and do that problem together, and solving this solving this triangle, which means to find all the missing sides and angles. Okay, and I'll show you how to go through that. And so here we go. Let's take, and I'll do a real quick drawing of it again, so I can reference it. This is 80 degrees. This is 18, 14A, and these are A, B, and C. So I have to find side A, and I have to find angles angles B and C. So choose something to find. Okay, you can do whatever you want. In this case right here, we're kind of set up to find side A. So let's go ahead and find side A. So since I'm looking for side A, I'm going to use the formula that has A squared, and then it'll be B squared plus C squared, and then minus 2BC, and then the cosine of angle A. That's the formula for a side A. Okay, and so then we plug in the numbers we know. This is side B, this is side C, and so A squared is 14 squared plus 18 squared, 2 times 14 times 18 times the cosine of 80 degrees. See? So this line has to be written for me. And then you want to tell me what A equals. So at this point, you don't need to solve this, by taking, you can write this step right here, or you can write this step right here, which is basically the same thing. I'm okay if you don't write this step. If you write me this step right here, I'm good. But you have to write me one of these two. Okay? One of these two has to be written for me so that I know that you know what A equals. And then after that, you can just go straight to the calculator. Please remember to round all your answers to 3 decimal places. It might be better for you to write this step down just because sometimes people do this step and they forget to take the square root. So if you write it this way, you'll get the square root down, and then you use your calculator, which I've already done, and you end up getting 20.796. And so that would be your answer that you would circle. So I'm looking for that, and I'm looking for that line right there. That's the approximation. Now, we need to continue. But you need to remember that when I continue to find these missing angles, okay, I'm going to have to use this value. So I am using a found value, and this value has been rounded off. You may use this rounded off value, and I will accept all answers as correct if you use it, but you need to be aware that by using this rounded answer in later work, you are generating and creating or introducing a rounding error into your other answers. Okay? And so if you want to avoid that as much as possible, right, don't round this off, just take as many decimal places as you can, and then use that extended answer in the rest of your work, and it should be a better, more accurate answer. But for our purposes in this class, you may use just this rounded off answer here in later work. All right, so with that being said, we need to find either angle B or angle C. So let's go find angle C. So if I want to find angle C, okay, I have this rule right here. Then I can go over here and I need to use this number right here, 18. So this will be 18 squared equals, and then the other sides. There's B squared. Here's the A squared. And then minus 2 times that, times the cosine of angle C. So now you notice that this over here has the variable. Okay? So I need to get to this. So what I'm going to do is I'm going to subtract the 14 squared, and I'm going to subtract that. And then I'm going to divide by this quantity right in front of the cosine. And so what it does is it looks like this. So the cosine of angle C is equal to 18 squared minus 14 squared minus 20.796 squared all over negative 2 times 14 times 20.796. So this step you need to give me. I don't need you to show me this step, but you might need to go through this step first. But once you get the hang of this, this is the step I want to see. Because to find C, I got to undo the cosine aspect. So we're going to use the cosine inverse. Remember when we used that in an earlier section. So the cosine inverse and then of this fraction. So if you can go right to this step right here. That's fine with me. If you need to do this step first, then do it. I need to see that line, and I need to see that line. Once I have that, then I can type this into my calculator. I have already done so, and I got 58.474 degrees. Okay? Now, I got to find angle B. Well, angle B is the leftover angle. I have 2 of them. I just need the third one. So it's 180 minus 80 minus 58.474. And so B is 41.526 degrees. And there you go. So these are the things I'm looking for. Okay? That step, the answer, and then your answer for the third angle. So that's how you can do that. Okay? There is an alternate way to do this. Okay? So just so you know, I think in the last lesson for Law of Sines, I didn't show you how to find the missing angle, but it's the same way. You'd have to use the inverse trig function to find a missing angle. So let me show you something else over here. Once I have A that we found over here, we used Law of Cosines and found A. Some people find the Law of Sines to be much easier to use. So I'm going to show you the alternate way that you could have done instead of this part right here. And that is using the A value, I have a complete ratio. So I could have done the sine of 80 degrees divided by the 20.796 equals the sine of angle C over 18. Okay, using the law of sines because I have a complete ratio now. And then I can do this process. And so what I end up with here is the sine of angle C is 18, remember, to multiply the diagonal, divided by the third number, times the sine of 80 divided by 20.796. Okay? So in the law of sines thing, this is what it would look like when you're looking for a missing angle. I need that step right there. I don't necessarily need this one, but I do need this one. This is the sine inverse of this fraction. So I need to see this line right here because this is what C equals. And then we can do an approximation, and I'll show you how this works on the calculator so you can see it done. So right here, let's see if I get the glare out of there. So I would go over here, make sure you're in degree mode, which I know I am. And so then I would go trig, sine inverse, do the fraction line, and then I would type 18 times the sine of 80 over 20.796. And control enter gives me, oh, maybe I'm not. Maybe I'm in radian mode. Yep, somehow I went to radian mode. Sorry, my apologies. Let me fix that real quick. Okay, so now I'm in degree mode. Sorry about that. We get back up here and then hit control and enter, and I get 58 and 474 degrees, which we already knew that was the answer from up here. Okay, see. So I can go the law of sines. Once I have a complete ratio, I can switch back to law of sines, and then the same thing would be for this. So if you go this route, again, you would have to show me these 3 steps, or in this one, you'd have to show me these 3 steps. So whichever one you're comfortable with, as long as your work is nice and neat and clear, I am okay with either one of the 2 methods that you choose for this particular problem. Okay? So there is the law of cosines technique. The other question over here we'll do in class, this is where I give you all 3 sides. So this one right here is definitely going to be using the law of cosines to find the first angle. Once I have the first angle, I can then branch off and do law of sines for the other angle. Okay? But we'll do that one in class. The other thing we have to do is there is finding the area of a triangle. Okay? Under the law of cosines techniques. And so this one, if you remember when we did the area of the triangle when we had the law of sines section, we had the sine as part of our rule. Here, we're going to have what's called Huron's formula. And he developed a way to find the area of a triangle from just knowing the side lengths. Okay? If I just know all 3 sides of a triangle, then I can find the area of that triangle, and here's his formula. The first thing you have to do is you got to find what's called the semi-perimeter, half the perimeter. So add up all the sides and divide it by 2, and that's what S equals. And then take that number and plug it into this formula. So here's the S, so whatever that is goes here, and then you times it by that number minus A, and then that number minus B, and then that number minus C. And you take the square root of the whole thing. So this formula right here will give me the area of that triangle. Okay? And so you want to make sure you know this formula. You will have a test question about the areas of triangles on your test using both methods, so make sure you have it. And so here I did an example. I'll just show you the example. It's this one right here. Okay? It's pretty straightforward. And so here's my triangle. I added up all the sides, divided by 2, got 4.5. So it's 4.5, and then 4.5 minus 3, 4.5 minus 2, 4.5 minus 4. You type that all in your calculator and you get an answer. Because I gave you units, make sure you put the units squared down. So here on this form is pretty straightforward as long as you remember how it works. But if you have any questions about it, please let me know. And so here it is for those who are copying this down. You pause and write it down. And then I'll come back to the other page too. So this is the first page. Here's the first page. And I'll let you pause there to copy it down. Okay? And then here's the rest of it right here. I'll let you pause there to copy that down. In case I went too fast. Okay, so there you go. That's 6.5. And we'll take more and do more problems together in class.